Okay, so let's look at Codeforces Educational Round 143, Problem A. We are given two towers and the towers consist of blocks which are red and blue. And there is an operation which we can perform any number of times. And the operation basically says that you can take any block from top of one tower and put it on top of the other tower. And you can do it with the other tower as well. So here the red block goes to the left tower, and here the blue block from the top comes to the right tower. So you can perform this operation any number of times and try to get two towers such that there is no repeating color, like over here. Over here there is no repeating color because it's blue, red and blue, and then blue, and red. Now we have to check if it is possible to perform any operations, any number of operations, to make the pair of towers beautiful. Beautiful is basically no repeating colors on both the towers. So let's see how to do this. Here I have taken the same example. We are given two strings. The towers are represented as strings starting from bottom all the way upwards. So this would be represented as blue, red, blue, blue. And this tower would be represented as red, blue, red. And we can take the element over here and place it over here, or we can take the element over here and place it over here. So this is the operation which is allowed, and we can perform this any number of times. Now let's try shifting the elements of one tower one by one over to the other tower. I'll write the towers down again. So we can put the blue from here to here, and now if we try to put it back, it won't make any difference. It will go back to the original state. So we can't keep going back and forth because it makes no difference. What we can instead do is we can keep on removing elements from one of the towers and placing them in the other tower. So this way we can use as many operations as possible. Now what we basically did by performing this operation is that this tower gets, these are two towers facing upwards, but this tower basically gets pasted over here facing downwards. In other words, we are appending the two strings by reversing the second string. Something like s1.append, s2.reverse. Now this observation makes our life easier. How does it do that? Because now we can see that once we have appended both the towers, if we need to split this one appended tower into two towers, then we can split it along only one line. The line can be over here, or over here, or over here, or here, or here, or here, and so on. Now, for those sequences where the pattern is alternating, like red, blue, blue, we don't have to worry. Over here also we don't have to worry. But over here, there's a problem. So we can solve the problem by splitting it. And we can split it only once. We can split the tower only once. So that is the only constraint. We'll have to find repeating elements, and we can split along those lines, but we can split only once. So if the number of repeating elements in this array or string is 1, then we can split it into two towers properly. But if the number of repeating elements is more than 1, then it's not a valid answer. So that's all you have to do. This is the first step. s1.append, s2.reverse. This is the first step. And then second, check repeating less than or equal to 1. Because if it is repeating more than once, then it's not valid. Let's look at the code. Let's see my accepted solution. Over here, I've taken the number of test cases and then n and m, which are the size of the strings. Now then I've taken the two strings and I have appended the reverse of the second string to the first string, and I've run a I loop from 0 to n plus m minus 1, which is the second last element, because we need to compare the ith element to the I plus 1th element, and we don't want an array index out of bounds exception. So we count the number of times there are repeating elements, and then if the count is less than or equal to 1, then we say it is possible to arrange the towers properly, else it is not possible. And as you can see, it has been accepted. Thanks for watching.